Looking at our first one here, we want to be able to look at the values in which we're inputting. We're using the f of x function. We're going to go and plug this value in. We should get 3a squared plus 4a. The other one I'm going to kind of do all in one expanse at the same time. So bear with me. You guys should be able to get it just by factoring and foiling. I'm not distributive and foiling. We should get 3a squared plus the AH plus 3h squared plus 4a plus 4h. Kind of a bigger one there. The next one down below, we got to be able to simplify this out. I'm going to do this all in one terms because I'm subtracting out both of these. My a's are going to go away. My 4a is going to go with my 4a, leaving me just whatever's remaining here. So I should get 6ah plus 3h squared plus 4h all over h. And then what we also want to be able to do is pull in the h to reduce down. When we reduce, we get 6a 3h plus 4. Okay, the bottom one is kind of a trickier one because we haven't seen something like this, but it should be kind of straightforward. We always say when we have a fraction, we look at the bottom portion. If there's an x, we want to be able to say that the bottom 2x minus 4 cannot be equal to 0. Okay, that's our first condition. And then we also have an upper condition with the radical. We say that x plus 2 must also be greater than or equal to 0. Okay, without that, we're going to have a negative value, and it's going to kind of look wompy, and we can't do it. Okay, so we have two conditions we must meet with these, and we're going to go ahead and solve those out, and then write our domain for these. The first thing we're going to look at is 2x minus 4 is not equal to 0, cannot equal 0. We're going to get 2x cannot equal 4, or x cannot equal 2. This is our first condition that we have. So in all our domains, we cannot let it equal 2. And the other condition is in which we have x plus 2 greater than or equal to 0. We say that x must always be greater than negative 2. So this is a second condition. Okay, so in this case, we got to write it with two conditions that are written for us. The way we're going to kind of describe this, I'm going to kind of erase this part up here just so I have extra room to write it. We're going to have two conditions. And the way that we're going to write this is x is equal to all real numbers, where x is not equal to 2, and where x must be greater than or equal to negative 2. So in these two conditions, as long as you have them in there, we're good. Does that make sense? Okay. That's all we want to be able to see here. Okay. Here's your answer key. This is your answer key. Look at your first two there. In the first case that we're getting here, we're solving out by making sure that the bottom is not negative. So we say x all real except where x is not equal to 3. The bottom one, what we did is we're going to go ahead and say that. What I did for the bottom one is I solved it out using the square root. So in this case, x cannot equal plus or minus 1. So we can just say that. You can also split them up. X cannot equal 1 or negative 1. Those are our two conditions. 39 is kind of a funny one. In this case, it's imaginary, right? Can we ever plug in a square root of negative 1? No. If it cannot be plugged in, then every other thing that we can plug in will be true, as long as it's not imaginary, but we're not going to plug in an imaginary number. You cannot graph an imaginary number in the coordinate plane. So in this case, it's just all real numbers. So in case you get a solution which can't be imaginary, oh, it's going to be all real. You're good. The bottom one's down here, and I'm kind of going to give you the explanation for this for 43. I didn't want to do it, but it's still going to be okay. For 43, again, we want to be able to make sure that the underneath the square root sign has to be greater than 0. So we say all real numbers except x must be greater than 5. And then the bottom one, I know there was, did you guys get x must be, or t must be greater than 1? Is that what you guys got? But is this a square root?
No.
What is it?
No.
Cube root. So in this case, it's not a square root, it's not a fraction, so in this case, it's all real numbers. It's all real numbers. Does that make sense? So no matter what value you can plug in there, the cubic root will always be a positive value. Now the numbers that we plug in are not going to be too large, but the numbers we can always get is all real numbers. Okay? As long as it's not a square root, as long as it's not a fraction, we can get all positive numbers from it. Cool beans? Okay. Take out your notes. We're going to do some notes. If you need to grab a couple pieces of graph paper, we're going to be kind of graphing a little bit, nothing too crazy. Nothing too crazy. Do me a favor, copy those down. Leave a little space to the right or left, because we're going to make some notes on that. And then try to copy that graph. I spoke to Mr. Brazo yesterday about how to teach this, just because I was unsure what it was really asking for. But essentially what 2.2 is graphing functions and understanding their behavior, understanding what graphs give you, how to graph them, the end behavior, what makes a function a function. Okay, what does a graph look like it's a function? What does it look like if you solve for an equation? How do we determine that? Does anyone know how we make sure that a function is a function by graph? What method we use? What is it called? Pencil method, the vertical line test. Yeah, that's perfect. Sweet, man. My first period was like, yeah, vertical line test will definitely help us determine that. And we're also going to look at both algebraically, what does it mean for us to solve out, and to see if there's any solutions that we can get a non-trivial answer, meaning it's not a function. So then we're going to also be looking at a new type of graphing method for you guys. Have you guys done piecewise function? Okay, we're going to look at graphing piecewise function. So I don't think we're going to get to that today, but we should be able to just look at the basic understandings of graphs, and then looking at domain and range. You have 2 homework problems tonight, which I'm going to give you, and that'll be the end. So we should just be simple today. Tomorrow we'll amp up a little bit by doing piecewise. They're not that difficult to do. Highly recommend you use Desmos to at least graph the basic idea of the function. But then we're going to look into graphing more complicated stuff by standard equation, by shifting left, opening up, opening down, vertical and horizontal shifts to those. So we're going to look at those as well. The first part that we want to be able to see here is when graphing functions, the key things that we want to be able to see here is x values are domain values. We also consider these inputs, and they always exist on the x-axis. I know these might be dumb, but it's okay. I'd rather make sure I'm covering everything to refresh you than to, hey, you should do this. I don't like teachers that do that. We have y values. I know how to spell values. Our range, in which these are outputs. These are on y-axis. And we can always refer to our points x comma y, our inputs to outputs, is the same thing that corresponds with x comma f of x. Where if we plug it into the function value, we're going to get an output value of whatever f is given us. These numbers represent our input values. These represent outputs. So we can kind of correspond this back to our number line. How many of you guys are going to homecoming? All of you? Ooh, I'm excited to see you guys there. I'll be checking you guys in, I think. For some of you guys, it's your last homecoming. Think about that. You know, last time I got dressed up was for a wedding after that. For reals. Think about it. Even prom. It's the last time you're going to get in a formal dress until you either probably get married or you go to a wedding. Think about that. It's surreal. It's definitely surreal. So I would say live it up. Live it up. Unless you go to college and then you have cotillion or formal. Those are fun. They do, but it's not like, it's like partying. It's not really, no one dresses up and it's pretty much everything. No, it's like, it depends on who goes too. It's not like the whole, like, Cal State Fullerton had 33,000 students. Not 33,000 students. But it was all fraternity and sororities. Really. And it was more so like a tailgate than they have homecoming, like a homecoming game. It's not the same. Think about that. It blew my mind. Some of your friends are going to get pregnant. You're going to go to baby showers. It happens. After they graduate, they start pumping out kids. It's funny. It's weird. It's weird. I had like 4 friends get their girlfriends pregnant out of high school. And now their kids are like in 2nd and 3rd grade. I'm like, what? It's adorable. Trust me, it is absolutely adorable, but you do not need to have a kid when you are in high school. Okay? Do me a favor, copy this time. We're going to go back to the other one. Yeah, it doesn't need to be perfect. It's weird.
Yeah. So was the graph on the first slide, was that like just a base thing? Or was it just an example?
Just an example. Just an example. There's no function value to it. We probably could describe it as a function of a graph, but we don't know what that function is. So copy down that. Doesn't need to be perfect. Yeah, I didn't get into a tuxedo till I was so my prom was the last time I got into a tuxedo until I went to a buddy's wedding. I was his best man. I was like 6 years after. Yeah. Adorable, I know. Adorable. Just adorable. To me, you really find out who your true friends are after high school, because then everyone dies out, because you're not going to see them every day here. You're going to have to make the changes to either hang out with them, or you're going to come to find out that some friends are going to be like, hey, spot me this time, and then they never spot you back. So you start going away from those people. I have a buddy who used to do it all the time. Hey, give me this time. Or he would go, I'm on a diet. And we'd go to and I'm on a diet. And then he'd peel off all of our french fries. I'm like, dude, where's the diet? You know? You have friends that do that already? Yeah, that happens. I'm on a diet, so I can't really eat down here. And then they just pick off all your fries. You're like, dude. And then people go away for college. People go away from the military. You don't see them. It's weird, man. It's weird. Yeah, copy the questions. People are gonna pass away. I had about 6. That was probably the hardest. I had 2 of my friends pass away from DUIs, get hit by cars. A couple of friends take their lives. Depression. It's real, man. It's real. It's, you know. You're not as young as you usually think you are. Like when I was 18, I'm like, I'm never gonna die. I don't care about dying. Not to say like I'm gonna take my own life, but it was, you know, skydive right now. Let's go. Wow, you know. And now I'm like, I'm okay, not doing that. Okay. Now that I'm under the weight, I definitely want to do it now, because you have to be under 240. And now no, not to hang glide is one of the most dangerous activities you can do. The most dangerous activity you can do. The mortality rate for hang gliders is more than any other, like kayaking or anything. Yeah. Skydiving is safer than that. Yeah, what do you think is the other way? Yeah. I'll do skydiving. Your relationships are going to grow. Some of you guys might think about it. To me, you don't really meet your soulmate until you're in college. So you might meet, you know, the person you're going to marry in college. Think about that. You're going to marry someone from college or wherever you go to. You're going to marry a coworker at a job you don't know. It's crazy. It's crazy. Real life. Hashtag real life. Yeah. To me, none of my friends, none of them are together with their high school sweetheart. That does not exist anymore. And when in college, I used to speak to, like, I had a friend that was together for 15 years. He was becoming a firefighter. He works for Riverside Fire Department. And at that time, that was right after Katrina hit. So they were trying to rebuild. So she had an opportunity to go and teach for America. So she was going to go to New Orleans. And she's like, hey, come with me. He's like, no. So what's going to happen? Well, I'm going to be down there for 4 years. So good times. Yeah, straight up. And she was she was the one that left him. And she was a super bitter bug about it. Bitter bug, man. Don't work out. Relationships don't work out in high school. I'm sorry. Hate to burst your bubble. You grow so much when you hit 21. You grow so much. Not the fact that you're partying, but you find out what you really want to do in life. To me, I found myself in when I was 21. That was my changing point in my life. T1 represents an input at 1 hour. At that 1 hour mark, we have an output of what? 25. So we're just looking at inputs and outputs. And then if we do T3, where input is at 3, we can look at an output of Oh. So T3 was going to be an output of, what was that, 30? And then an output of 5 at 5 o'clock. We're going to look at an input or input at 5, output at 10. Are these easy to do? Yeah. Okay. We want to be able to compare which is larger, either T of 2. So if we input at 2, we're going to get 35 degrees. Or an input of 4 will give us 15 degrees. Which is bigger, T2 or T4? T2. Okay, so our input values correspond to the way that we look at inputs to output values. So we're going to look at different types of those. Okay. The next thing we're going to kind of look at for these, okay, and let's just kind of do this next one here. Just describing functions, so we can look at inputs and outputs. Evan, yeah, it can be, again, very free-handed, very nonchalantly. It's not until we get into the other crazy stuff that you need to. Evan and outputs, even in odd functions. We're also going to be describing these. If I give you some type of function, can you tell me what it's doing? Can you tell me the end behavior? Will also be crucial when we're talking about functions themselves. It doesn't need to be simple. One thing that we're getting with even types of powers is that they're both going in the same direction, either both up or both down. If it's odd, meaning the power that you see in the polynomial, one's going opposite direction. So either they're going both, one is opposite up or down. Okay. The way that we can describe this is powers of x describe end behavior. If it's even, both will either be going up or both going down depending on the negative or positive. If it's an odd type of behavior, meaning x to the third, x to the fifth, meaning it's going to be odd, one up and one down. And again, depending on the orientation of our a value. But we're going to kind of get into that later. So I just want to explain this that portion to it. And then I got into like some health kicks. So the only things that I was having was I was having a bowl of rice with chicken, teriyaki chicken. I had that every day for like 6 months. Yeah, every day for 6 months. Yeah, it was actually pretty tasty. Yeah. I was lazy. I was so busy. I was on campus all day long. If I wasn't on campus, I was working. If I wasn't working, I was studying. If I wasn't studying, it was like I didn't have enough time to like make decent meals. You appreciate how much your mom and dad, or your mom makes for you. I don't know if your dad makes food. But the times that I would go home like once a month, you know, I would like, hey mom, make sure, can you make me this? Can you make me that? And she's like, yeah, mijo, I got you. I'm like, yes. Cook it up. Okay. Copied on this as well. Copied on the graph. Graph is important. Write this. That your domain can be mapped to the x-axis And your y and your range can be mapped to the y-axis. Meaning, the same color. Far left, far right. This is going to be your domain. In this case, the farthest left of my interval is going to be here and here. So our domain is going to exist between these two values, whatever they happen to be. If we're looking at the range is going to do this. Top to bottom of graph. This is going to be your range. Meaning the top value is going to go all the way to my y. In this case, it stops here, so this is going to be my range value. Okay, we want to be able to identify these. Do you guys remember doing mapping or finding domain and range of certain functions? We're going to do that same kind of idea. You got to be able to map them. Using graphs to actually map the function first to determine the domain and range is very, very assistive and helpful. Okay, and being able to see whether you have integer points or locations of these. It's also good to know that you can also box it. If you box up the whole domain or you box up the whole range, if it can be boxed, it will also do that same thing where you can map them directly to each part. Okay. Here we go. This is, we're going to look at more of these stuff tomorrow. So piecewise, we're going to do piecewise. Okay. This is your homework. Don't freak out, please. You're only going to be doing these ones, 24. This will be posted today. I just haven't had time to get a screen capture of these. Okay. Domain and range. You will also need to put D in here for this. Find domain and range of G and F. I'm going to do the domain for the top one here. Our domain values for this top one. So I'm doing B for you already. Our domain can be written as an interval, meaning I can map this by mapping all my points down to my x-axis. So in this case, I'm going to go from -4 to 4. And then my range can be going from the topmost to the bottommost, which will be 3 and -2. So we'll do more examples of these, but just try those out. That's it. That's it for you guys.